Good morning and welcome everyone to today's webinar on how to identify and prevent web application hacks before they happen. So before we start, a couple of housekeeping items. You will notice we are using the GoToWebinar viewer today. If you look at your control panel, the little orange panel will let you expand and hide that. This is where you can choose on how to listen to us today, either via microphone or a speaker or the telephone. You will all have joined us in listen-only mode. That means you're muted to cut back on the background noise, but that doesn't mean that we don't want to hear from you. So feel free to chat with us and drop any questions via the Q&A or chat window, and we will address them during the Q&A session of the webinar. The webinar recording will be sent to all webinar participants post the event. So I have Venkatesh Sundar, or Venki, as he's like to be called. He's the founder and currently the CMO at Indusface. He is responsible for international growth. Though a marketer and business dev role now, prior to this, he was the core engineer, CTO, who built the entire Indusface technology stack ground up. Everything that you're about to see and demoed, the product and team was designed, built, and led by Venki. So a hardcore technologist turned marketer now. My name is Nikhil Dasa, and I'm here with you from the team at Indusface, and I'm here to help monitor the questions during the Q&A. So in today's webinar, we will learn how to get into the mind of a hacker, go beyond the basics, how to track the intent, and we will be doing a live demo. With that said, I'm going to hand it over to Venki. Venki, you can go ahead and get started with the presentation today.
Hello, thanks, Nikhil. Thanks, Nikhil, for the wonderful introduction. And I think building on top of what Nikhil said, I'll try to keep it short for 45 minutes. And I would like to spend a lot of my time on the demo part, which will be the last 15 minutes of my presentation. The theme of this webinar is how to identify a hack before a hack happens on your application, right? So to do that effectively, we have to look at how to get into the mind of a hacker. What are the things they try to do before they try to plan an attack and do an attack on your website? And once you have an understanding of that, then you can take targeted steps to protect yourself against the hack attempts. So to get into the mind of the hacker, what is it that they do? And what needs to be done has to be understood, right? So a hacker, to get into the mind of a hacker at a most simplistic level, you need to understand what is it that they do to hack your website, right? At a most simplistic level, what they do is they run automated tools and they try to find weak spots on your websites, and they try to do a targeted attack across assets having your vulnerabilities. Okay, so why do they do this? They are also trying to build automation and try to get the biggest bang for the buck. So they run the automated tools. They try to find the weakest spots that they can use to do a targeted attack on your application. That is, in a nutshell, what a hacker tries to do, right? Instead of trying to shoot in the dark. So in a nutshell, what a hacker is doing is DPM. They are trying to detect vulnerabilities. Then they are trying to perform an attack and monetize on it, right? So detect vulnerabilities in a large scale on finding out a target assets that they can go after. Plan and perform an attack, and then monetize that attack. either through ransomware or through political mileage they can get in case it's government. There's a bunch of motivations on which they can do it. Right? So DPM is what a hacker does. Double clicking on that, clever hackers do a DPM using advanced automated tools, and they do targeted attacks on the weakest spots that they have identified, and then they monetize it. Right? So they get scale. Now I'll get into what we can do and to prevent against this. So I think if you look at the theme was how to get into the mind, how to stop a hack before it happens. I'm not talking about log analysis and profiling and artificial intelligence, right? I'm getting it down to the most simple level on what is the way a hacker tries to plan an attack and how do I capture that behavioral intent. And then once I understand that, we can take focused steps to prevent yourselves against those attacks. So how do you stay one step ahead of this approach a hacker takes? So I think as business owners, we have an unfair advantage over a hacker. The hacker has an unfair advantage because they have no boundaries, but we have an unfair advantage because we just have to take care of one application, that is my application. Whereas a hacker is trying to probe all the vulnerable applications across and then try to do a targeted attack against vulnerable applications. Whereas you as business owners, you don't have to worry about other applications. You just have to worry about your own application. And we can do the same detect, protect, monitor or DPM, but with a twist. It's a detect, just like a hacker does. Instead of performing an attack, you protect yourself against those planned and performed attacks, and you monitor what they are trying to do, and then you try to improve your defense posture based on that. Right? And you have to do this only on your application. So the scope of what you have to do is very small and focused to only your application, and that's why you have a little bit of an advantage over the hacker and try to stay one step ahead. So we at Indusface call this approach as total application security. We don't talk about pen testing, scanning, automated scanning, and web application firewall. Those are all technical modules under the umbrella of application security. Right? So total application security that detects, protects, and monitors, where detect, protect, and monitor is the use case. Detect to find out what is your risk, protect to immediately protect yourself against those risks, and monitor against what is happening from an existing vulnerability standpoint and from an attack standpoint to keep on improving your defense posture. Total application security, one-stop shop to fix all your application security issues. You run your business and we take care of the security, and taking this use case driven architecture centric approach towards application security. So I don't, 10 years back I had to do a lot of preaching on why security, but today most of the attendees or most of the people I talk with, there is certainly an understanding and at least an acknowledgement that application security is needed. And especially with the public cloud adoption, one of the primary reasons or drivers for security is people are trying to build their business at speed, and agility is very, very important. And application security comes in the way of the agility. So all the public cloud, single-click deployments, and the speed at which you can build new functionalities and roll out new functionalities is extremely important. One of the cliches is it's not how big you are, it's how fast you are that determines your survival of the business. So security cannot come in the way, and application security specifically requires very focused expertise. So with that, there is a big pain point based on which a very focused set of application security expertise is needed to take that pain away and also not come in the way of speed and agility. Right? And the public clouds, you will also find out that people, the hosting providers or the data centers, they say that security is a shared responsibility. As a hosting provider, they will provide security at a network layer or at a hypervisor level and below. But applications is owned by the customers and the business owner, so they are responsible for the application security. And that is where we at Indusface come in and try to take it down to a most simplistic use case of how to identify a hacker and prevent yourselves from hacks before they happen. So I'm going to double click on the DPM, not from a hacker standpoint, but from a DPM from a security protection standpoint, detect, protect, and monitor. So why detect, and what should we do in detect? Right. So you might say that you have a very strong secure coding practices, as part of the software development lifecycle, security testing is part of your software development lifecycle. But web applications is a different beast, and no application is an island. There are many moving parts. Your application itself is running on a third-party web server, operating system, application server. It is probably interacting with many third-party web services and APIs that is probably not in control or owned by you, even though you own your own application stack. So there are many moving parts. And another cliche is your security is only as strong as your weakest point. So any of these moving parts and a weak spot in this moving part can create a significant security risk to your application. So there are some challenges with the complexity of the application and the number of moving parts. So what has to be done to address those challenges? You take the same hacker approach of doing it automated, but also with an advantage of doing it much more comprehensively. A hacker is not going to be able to do a comprehensive application testing as well as you as an application owner can do, right? So they will be trying to get speed in terms of trying to find the weakest spots, and they will be doing just automated tests and try to find a weak spot. Whereas you as an application owner can keep doing automated tests continuously and periodically to at least get the same view that hacker gets, but you can also combine it with a much more comprehensive application testing with manual penetration testing, which is business logic. An example of a business logic is I log in as Venki and I access John's document, right? That's a privilege escalation, and which is specific to the use case. If it's a document management system, the fact that I can view John's document is a business use case relevant to their application. Or if it's a banking application, the fact that I can view somebody else's statement is a business use case. These are business logic testing, which automated tools cannot effectively find it, right? They might be able to find very simple things like SQL injections, cross-site scripting, and so on and so forth. So you do it much more frequently than a hacker can do it with automated tools, and you do it much more deeper than a hacker can do it with manual penetration testing. Right? And you also increase the coverage with a comprehensive set of stack by going with a vendor, not necessarily Indusface, anybody, who will provide you continuous scanning, deep manual penetration testing, provide you support on what has to be done for you to fix it with complete guidelines on how to fix it. You do this frequently and much more deeper to stay one step ahead of the hacker, and you have an advantage because you had to do it only for your applications. And hence you have an unfair advantage for doing it better than the hacker. Now that you have, once you have done the detect part of it, protect is at a very simplistic level. You have to fix it in the application, right? Because the right place to fix it is in the application, but there are still some challenges on why a protect cannot be done in the application. And I will talk a little bit more about what those challenges are, right? Detection alone cannot prevent attacks because detection alone just makes your blood pressure high because you have found out that you have a risk and you have to immediately fix it. And if you own the application, it is probably an obvious thing that you should be able to fix it quickly. But here are some data points that we have based on the 3,000 plus websites and the 900 plus customers we have been serving. We found out that 80% of the critical vulnerabilities remains unpatched for 6 months. Even after making it known. We found out that 90% of the vulnerabilities remain unpatched for more than 4 months. These are some of the data points we have. And here's another data point where there might be some organizations which are very agile and fix it very quickly. If I take out those organizations that fix it, let's say within a day or 2 days, or any organization that fixes a critical or high within a week, and then I look at the average of other people, it is more than 200 days. So people who fix it within a week, and those who don't fix it within a week, they take more than 6 months. Now, why would that be? No business owner would want to do it deliberately, right? The reasons are multiple, and it ties into the point I mentioned before. There are many moving parts. There are many third-party applications on which you do not have control, and patching them in a timely manner may not happen within days or weeks all the time. Right? So there is nothing worse than knowing about a risk and not being able to do anything about it. So the term that is there in the industry is called as virtual patching, which will allow you to get a quick time to fix on the known vulnerabilities immediately, right? And with our expertise on having done 3000 plus, our existing sets of policies addresses more than 70-75% of the attacks that we have found through automated tools automatically out of box. We have ready-made templates and policies for that. Now you might come back and say that you can still fix it within a week. If you belong to the category of people who fix it immediately, there is still a value in why a protect layer is needed, where in addition to you fixing it in your application, there is still value in putting a policy in a protect layer or a web application firewall, which is one of the themes, which is not just virtual patching, but to be able to identify the behavioral intent of a hacker. Because if that policy gets hit, it is leaving behind a footprint of a behavioral intent of a hacker, which can be the intelligence based on which a much more aggressive defense posture can be taken. And I will be demonstrating that going forward. So time to fix is just the tip of the iceberg. Detection alone is not enough. Protection is needed. And protection is also needed not just because of existing vulnerability, but the ability for giving an open door for trying out and experimenting multiple things that exist. Because web by design is meant for open usage and meant for the world. So you might have the best network firewall IDS, IPS, but HTTPS traffic are typically allowed without any controls in place. So legitimate users as well as attackers can come in. So some of the data points on why application security is such a big thing is 75% of the attacks happen on an application layer because it is easy for a hacker. We also want to point out, Gartner says that application security is such a beast that it is better to go and take it as a service as opposed to a software that is piece of box that is installed and then you'll have to scratch your head on how to manage it. It is best to have application security taken as a security as a service, right? 451, one of the data points they gave, which allow is expert tuning and continuous updates can be the difference between a working defense layer versus something that is just gathering dust. So this is where I'm saying it's not just virtual patching and forgetting about it. That virtual patch policy is going to give behind a footprint and of an attempted attack attempt, which can be the intelligence based on which further tuning and further automated updates can be done to improve your defense posture to keep the hackers out and prevent a hack from happening before it happens, right? So now it's a good segue into monitor. So I said virtual patching alone is not enough. It's just tip of the iceberg. Monitor is where the real value of a policy comes in. Because when somebody makes an attempted attack attempt, that footprint can be a feed into the monitor to know what is happening, where the attacks are coming from, and based on which can I dynamically update and take a different posture. So here's an example I can give here, and which I'll also do in the demo later on. One of the recent vulnerability that comes to my mind is Apache struts. Right? So Apache struts vulnerability, it was a vulnerability on a framework. Any struts application that is running on a specific version of the framework had a vulnerability because of the struts vulnerability where somebody can take control of the operating system on which the application is running. How do they do that? The application is running on HTTP protocol. They inject a command through the HTTP protocol, and the command gets executed on the target system where the application is running. And from that point, all bets are off. Now, through the policies, in fact, our core rule set policies based on command injection rules out of box had a policy to block command injection. So I cannot execute a command injection payload on an HTTP request, right? So this policy was zero-day attack was blocked from even the day it was made known. Now, just the fact it is blocked is not enough. What we also found out was any person who is trying to inject a command and trying to exploit this threat's vulnerability is a guaranteed attacker. If it's an authenticated user, you as a bank can say that this particular user should be blocked out. or blocked out for the next 5 minutes because he's trying something funny. That is the intelligence. Again, I'm not talking about any learning and log parsing. I'm just talking about a very simple one use case where I had a vulnerability which was made known, and I know that an attacker is bound to have this behavioral behavior of trying to exploit the vulnerability using these payloads. And if the payloads are found, you know that the person you're dealing with on the other side is guaranteed attacker. Based on which, if it's an authenticated banking site or an authenticated user, you can block out that user. That is a dynamic defense update that I'm talking about, which only monitor can provide. Right? So monitor is the most important. Continuous inspection based on your existing vulnerability, attack patterns, and the incidents monitoring is important to keep your security posture up to date. I am going to give a demo on this aspect on a different use case, which I will talk about before I get into the demo. So monitor, detect, protect, and monitor, and proactive learning with analytics, which of course I did not talk about machine learning and all those things, but of course as we deal with gigabytes of data, those are going to have a role to play. But as a business owner, you are interested in very simple use cases. How does a hacker do an attack? Can I accurately identify a behavioral intent of a hacker and immediately protect against those hack attempts before it happens? Even before getting into advanced analytics and machine learning and all those things, there are very simple things you can do by taking the same DPM concept that a hacker does, which is detect, plan and perform attack, and monetize. Instead of that, you detect, protect, and monitor those attacks and get those behavioral intent and accurately and effectively. So now we'll go into the demo. So what I'm going to, the way I've structured the demo is, I've structured into two parts. The first part is I'm just going to give you a portal walkthrough of, you need, as a business owner, wouldn't it be great if you have a single view of what is my current vulnerabilities, what is happening from an attack standpoint, and what is being done from a management standpoint. These are the three things I talked. The vulnerability I have picked up is something called as no server-side validation, which I'll explain when I'm talking about that vulnerability I'm doing the demo. Okay, so I'm just going to go into my portal screen. So this is where I am logging in. So any user who subscribes to a total application security service from Indusface will get access to the portal. Right. So in this portal, if let's say you are subscribed to mybank.com, and the mybank.com is protected using TAS, you will have the deployment done in front of your application, and those events will be consolidated, synced, and the scan reports and the attack reports and the monitoring updates will be provided in this centralized portal. And then each of the customers will get a test for logging into this. So let me log in here as a test user. Okay. So I have logged in as a test user, and what you have is these are the sets of assets that are protected behind the TAS service. And each one of them, they show you what is the configuration status, which means if your protection is the routing happening through the protection layer. In this case, the routing is not happening through the protection layer, so the customer has to do the routing. This service can either be placed on-prem or it can be done over the cloud, where we host the infrastructure. So for the purpose of this demo, I have a vulnerable site, vulnerable.indersecure.com, which is protected using TAS, and the website name is qa1.indersecure.com, right? And then when I click on this, each of these assets, it will give you the status or the summary of what is the current set of vulnerabilities that exist in an application, what is the number of attacks that has been carried out targeting one of your existing vulnerabilities, and what are the total number of attacks. If you go back to the DPM concept, this is bound to happen. I have seen this happen time and time again with many of my customers. They have a vulnerability at some point, not immediately after the vulnerability, at some point, if they have even one vulnerability, they will see a spurt of attacks probing and targeting those vulnerabilities. Now, if you have a protect layer, it is giving you visibility that there were X number of requests that was trying to exploit one of these existing vulnerabilities that you have in your application. Don't worry about it, you are protected. This is the perform attack part of the hacker being blocked effectively with the protect part of the DPM from us. There are also other attacks that gets blocked. DDoS is a big pain point, and you get attack categories, IPs they come from, countries they come from, URLs. But for the purpose of this demo, I'm going to stick to these points. These are hack attempts being blocked before a hack happens by knowing the behavioral intent. Right? How do we do it? Because we do a detect. In the detect, we have found out what is your current vulnerabilities that exist, and a report that can be downloaded, and what are the types of vulnerability that exist. I am going to quickly show you the report that I have already downloaded. So one of the report that I have downloaded is on the qa1.intersecure.com website, which is server-side validation not in place, which means somebody can enter a data and the validation logic is on the client-side browser, and the attacker can bypass that logic. This is a medium vulnerability, and for the demo purpose, I'm going to take this and demonstrate how a hacker behavior can be identified. In the protect, it gives you what are the attacks, where are they coming from, how many of them were critical attack attempts, high attack attempts. These are, don't worry, they are blocked. Right? It shows you the protection layer part of the solution and tells you what is happening from an attack standpoint. And the monitor will tell you what is happening from an update standpoint. How many custom rules got created, how many vulnerabilities got addressed through those custom rules. What are some of the suspicious attacks that we are seeing which can feed us intelligence to do an advanced defense posture. Right. So this is a detect, protect, and monitor to counter the detect, perform attack, and monetize from an attacker. Right. Ransomware, we have had customers who have been exploited based on the DPM concept of a hacker. They found a vulnerability, or they found out that they can easily succumb to some kind of a DDoS attack. They tell that on this particular day we'll carry out an attack if you don't pay me 2 bitcoins. That's classic detect, perform attack to find vulnerabilities and then monetize. Right? So you stay one step ahead by doing a DPM. Now let me get into the demo part of it. So the demo, the way I set it up is I have 2 sites, one without protection and one with protection. Both of them are the same application. The one without protection, I'm calling it vulnerable site.intersecure.com, and the one with protection, I'm calling it qa1.intersecure.com, which is what you saw in the portal. Now go back to the report I said. In the report I said there is something called as client-side validation only enforced, no server-side validation. So let me demonstrate that in the vulnerable site, which is without task protection. So I'm logging in as a user. In this is the application that I'm logging into. I log in. So this is a vulnerable application which has got many vulnerabilities. One of them is client-side validation not enforced. So there's a bunch of attacks for the purpose of demo that we can carry out here. One of them is client-side validation hack. So I'm clicking on the client-side validation hack. Basically, it's on the password field. So what we do in this client-side validation hack is the functionality is to enter your current password and enter your new password. So I'm entering my current password, and there is a logic here that the new password has to be at least a certain characters in length, it should have some special characters and so on and so forth. So I'm trying to break that logic and click on change. and click on change, and it says the new password is not valid because the password policy minimum 6 characters length containing at least one uppercase character, lowercase character, number. Now this validation is enforced on the client side. There is no data going over the wire here. It's a JavaScript code that is doing it. So the user cannot bypass this logic, a normal user. But a hacker might do something here. So that is what I'm going to demonstrate. So the hacker might enter something that matches the client side policy. I'm writing test 123, test 123, and I'm going to turn on local proxy where I hit on change. And as soon as I do this, you see this was my current password. This is the new password that I set to get over the client side validation, which I'm highlighting here. Now I'm going to modify them to 123, 123. And now hit forward. Turn intercept off. Password has been changed. So once again, recap of what happened. A normal user was not able to enter the password 123 because it breaks the policy. There is a validation enforced that it has to be a certain character in there. That validation is enforced on the client side. The hacker has found out that it is enforced only on the client side. He is trying to manipulate that parameter, break the policy by first giving a right value and then manipulating it to a wrong value and sending it to the server. The server side did not enforce the validation. And the password actually got changed to 123. Now if I log out, I can log back in at 123. I have bypassed client-side validation. Now take a step back. There was no major damage done on the application yet. The hacker has set himself a weak password policy. But think about it. Why would somebody do that? This is not normal browsing behavior. They have bypassed a normal path of a normal user flow to get something done. Whether that something is malicious or not is a secondary question. The very fact that they have done this is not a normal user, and it is a probing. It is part of the detect, plan and perform attack part of the DPM of a hacker mindset. And they have done that. Now I do the same thing behind a total application security protector application. Just to demonstrate that it's the same thing, I'm going to log in as the same user. The modified password is now 123 because this is what I modified by bypassing the client-side validation. I log in. When I log in, this login will be successful, and Venki demo user 1 is already into the website. Now, because this is behind WAF, let me try to do the same attack, bypassing client-side validation password, but this time with the application behind WAF. So what I'm demonstrating here is a protect layer having a policy that says that the password has to have that validation logic that we have on the client. You still can put it in the application and fix it with server-side validation, but by putting it in the protection layer, I now get a visibility into an attempted attack attempt, and based on which I can take some steps, which is what I'm going to do. So right now the current password is 123. Let me go back here and turn intercept on again so that I can be the man in the middle, which is the hacker. Hacker is trying to change it to something valid first to bypass client-side validation, just to show that I'll set it to something low. When I do a change, yes, it has to be minimum 6 characters long. That is what you get here. So client-side is validating this. Nothing went over the wire. Now let me change it to something as per the validation policy. I click on change, and you see that my current password is 123. I have changed it to this. Now let me change it back to ABC. ABC, and I click on forward. The protection layer blocked it. Something malicious has been done. Once again, just in case, once more, 1, 2, 3, I'm changing it to ABC, ABC, and then hit forward, blocked. Now, I can have a policy that there is somebody who is trying to repeatedly try and bypass client-side validation. I know that this user is Venki Demo 1. I know that there is an active session against this Venki Demo 1, and he is not doing normal user behavior. This is the monitor part in action, where now, because I have crossed the threshold of tolerance of bad attempts being attempted, now if I try to do anything, the session is blocked. Let me turn intercept off. That session is blocked. The user cannot do anything. I cannot browse the website because I have a session, that session is blocked. This is the demo that I wanted to show and show the value. I did not do any log file part. It's a very simple behavior intent that was identified for this user. The behavioral intent was they bypassed a normal browsing behavior and they logged in. And they tried to do some tampering. Without TAS, it was allowed. With TAS, it was blocked. Not just blocked, but because it crossed the threshold and we know that we are dealing with a guaranteed attacker on the other side, it was blocked for the next 5 minutes. So this particular user will be blocked for the next 5 minutes. Or this session is blocked for the next 5 minutes. That policy can again be customized to block that user or blacklist that user and build a reputation. It is not just IPs, it is identities. If it's an attacker who is an authenticated user, you can have a reputation for the identity which you as an application owner control. So even before the hacker can try out something, at some point in his DPM cycle, he has been blocked out and cannot proceed further. This is the unfair advantage I'm talking about that you as the application owner can get without getting into doing anything complex. Very simple DPM principle to counter the DPM principle of a hacker. Right? So I think with that, my demo is done. I would like to open it up for any questions.
Okay, thank you, Venki. And I think the audience, I'm sure, has got great insights, especially to application owners who are present here in terms of how to go about securing the application. So I've got a few questions from the audience here. So let me put the first question out here. So if you block off an attacker, how can I do ethical hacking testing which will have those payloads?
So if you are doing an ethical hacking testing, very valid question. If you're doing an ethical hacking testing, then that particular ethical hacker will have some test credentials or they will be doing it from test machines. So those things can be whitelisted to not be part of this policy. So that ethical hackers, known ethical hackers who are engaged with the permission of a business owner can be whitelisted to not be part of this policy, either at a credential level or at an IP level.
Okay. So I'll just take another question from one of our attendees here. So he was asking, can we set the block policy based on attacker? In your example, you block the session user for some time. Can I blacklist the user permanently or some other customization?
Of course, yes, which is one of the things that I mentioned, where in this example, I just block the session, but you can block the user. You can have a reputation which through custom rules, which through the application owner can be updated to have policies as per the business owner's requirement or the application owner's requirement.
So I'm going to take one last question, given that we are struck for time here. So this one question is from one of the attendees, and he is What if the attacker carries out an attack that is outside the attack pattern identified by the scanner or ethical hacking?
Fantastic question. I think that's a $1 million question as well. So if they carry out an attack that is outside an existing vulnerability, you are protected to an extent that at least your application is not vulnerable, or you think it is not vulnerable. But a protection layer can still have policies which can be independent of your existing vulnerabilities and also custom rules specific to your existing vulnerabilities. So those policies which are independent of your existing vulnerabilities, more or less covered some of the common patterns, will provide protection against this, where it is not a attack pattern targeting your existing vulnerabilities, but a generic attack pattern. An example I can relate to is, let's say, struts. Struts vulnerability is something based on command injection, right? You might not have a struts vulnerability applicable to you, but if somebody is doing a command injection, that is an attack pattern which is not targeted to one of your existing vulnerabilities, but will still be blocked, and it's still a visibility of something malicious being done. So this is what we call as common or core rule set policies, which are generic attack patterns, which has to be updated with test cases and new things. And the other thing that we call is custom rules policies, which cannot be blocked through core rule set, and you have an existing vulnerability, you can block it through custom rules. So together they provide a complete risk mitigation. And with updates to zero-day research, zero-day vulnerabilities, and other things coming up, we can keep updating the signatures to keep providing broader coverage.
Okay. I've actually got few more here.
We have some time. I've got a little bit done early.
Yeah. So I'll just take few more questions here. So one question I think is very straightforward. Can we block the IP of a hacker?
Yes. I mean, so again, IP as an identity is certainly one of the most simplest of rules to do. But what if an attacker, a hacker, is coming from behind a natted IP from within a company? Then blocking their IP will block that company. That's a risk that can be taken. But certainly, as a policy, we allow IP blocking, and it can be very effective. And what I would recommend is not permanently blocking their IP unless their IP has a bad reputation, because it can be a bad user behind an IP, or it can be a bad IP with a bad reputation, which feeds like Project Honeypot and everything provide. So certainly IP blocking is the most fundamental and basic level of action that can be taken, and block their IP for a few minutes can be more effective than permanently blocking out their IP unless their IP has a bad reputation.
Okay. So the next question I have here is, what if one tries to hit the same URL grammatically? Will this also be protected?
Can you repeat the question?
What if one tries to hit the same URL grammatically? Will this also be protected?
I don't understand what does grammatically mean.
I think this is programmatically. I think.
Okay, programmatically. Okay, all right. Okay, so if we attack the same URL programmatically, okay, that is a classic. It can be site scraping. It can be a very basic form of DDoS attack of get flooding or something. We have rate controls in place, and we also have something called as CAPTCHA, which can be very effective throughout. So you can have a policy which says that if the same particular URI from the same particular identity gets hit X number of times in Y minutes or Y seconds, then throw a CAPTCHA, where X, Y, identity are customizable attributes. Right? In this case, it is IP, and the attribute can be rate, number of requests per second, and the action item, instead of blocking it, can be a CAPTCHA to distinguish between a human and a bot.
Okay, so I'll just take one last question here. So, are there signature updates for network security?
That is one of the key aspects of the monitor, and one of the recommendations to go to an application security expert, either Indusface or whoever it is, to take the pain of application security away from you, because it does come in the way of the business. And one of the most time-consuming aspects which requires a lot of time is updates to signatures and policies effectively and in a timely manner. So signature updates are an ongoing process. In fact, our release cycle is almost a couple of updates every week, based on zero-day attacks that are happening. We send out advisories on these zero-day attacks. How many of them are already blocked with the existing core rule sets? How many of them require a custom policy? How many of them cannot be blocked? Some of them cannot be blocked unless because the attack payload is not known yet, right? So those advisories are done, and then joint call between the application owner who runs his business but cares about security, and the application security experts can be taken to keep it managed.
So yeah, we actually have a lot of questions this morning, but I think I'll take one last question now. So this was a connecting question from the previous question. So what will be the impact on the performance of my application?
So here's my view. The performance in the application will be minimal, but it's got a couple of factors. Number one, placement of the service. Number two, encryption. These are the two, and number three is caching enablement and everything. So at least I will talk about what Indusface and our solution. We have an architecture where if it's SaaS provides you the ability to onboard quickly without any infrastructure and resources from your side. But you have to pick a region that is closest to where you are currently hosted. So we have multiple data centers. We are in a public cloud. We have a data center in India, and we have in US and other regions as well. So picking a region where the routing happens closest to where your application will significantly minimize. And in fact, a lot of places it is almost zero. And in some cases, believe it or not, it is actually improved because application has not been tuned for connection pooling and caching as effectively as we have done it. So in some cases, it has actually improved the performance. And in many cases, it is actually absolutely no impact. Second is actually encryption, right? SSL encryption. So if you offload the SSL, do you want double encryption all the way to the end or HTTP? Especially on the cloud, you need double encryption. So that will have some impact. But more than the performance impact, you have to think about the user experience impact, right? So the user experience impact, at least for cache content, it can be done through this, there will be no. But for dynamic content, you still have to talk to the application. And the user experience impact, studies are showing that if it is in milliseconds, even with double encryption, typically that is what we find, the user experience impact is not very high. Even though as a percentage, there might be some overhead, 20 milliseconds, 30 milliseconds overhead, but there is absolutely no visible overhead to user experience. And those things can be tested as part of the onboarding to make sure there is no impact and then take the right call.
So yeah, I think with that said, I just want to thank the audience for all your questions, and I'm sure if you missed answering any of your questions, we will make sure to reach out to you all post this webinar with your inquiries. So we've also set up a quick poll, which will just throw up now. I would encourage you all to. So I just encourage you all to give us your valuable feedback on this webinar. The poll will last for 10 seconds starting now. So I encourage the audience to visit the Indusface blog page. It has great knowledge base and topics related to application security here. So you can, we have the URL here. So maybe after this webinar, you can just go through and skim through the blogs which are related to your business use cases here. So yeah, so we do encourage you all to take a 14-day free trial of our TAS solution. For this, you can reach out to us at marketing@indusface.com, or you can visit our website at www.indusface.com. So thank you, Venki, for your valuable insights, and the audience for taking your precious time to be part of this webinar. So see you all till our next webinar, and take care and have a great day. Okay, thank you.